All right, hey, welcome to hotscience.org. Today we'll be talking about half-life, specifically focusing on the half-life graph of carbon-14, as you see behind me. Just kind of talking about, what is it can we learn from looking at a half-life graph? How can we use it? What are we going to see it? Coming up test, right? That's what it's all about, passing that test. So let's take a look here. So here we have the half-life carbon-14 graph. First things first. What is here? What is on this graph? What story does this tell? So down here on our horizontal axis, right, on our x-axis, we have our time variable. So anytime there is horizontal movement of our line left to right, we're talking about time, a longer, more and more and more and more time, right? Down here it took longer to get here than it did where to start because we move left to right. Then we got our vertical axis here, right? We got percent remaining. So any move or any shift, right, up or down, we know we have some change in the percent we have. Up here at the top, this is our full 100%. This is our entire sample amount that we started with. If we ever did reach zero, which we never would on this, um, that would be at the bottom, right? So when you're thinking about these graphs, any graph, any line graph, we got two axes. We got x and y. Try to tell you, think about the horizontal component, right? Think about the vertical component separately, right? Ask yourself, if you're thinking about time, follow the graph, right? Am I moving left to right? We tend to follow with our eyes, like, okay, I'm moving at an angle downward, kind of looping to the right a little bit. But just think about it as up or down, left or right, and do it separately. So as you're following your graph, I'm moving left to right. Okay. The only way I would not be moving left or right is if my line was straight vertical, right? Am I moving up or down? Yes, absolutely. So you can look at them separately, and I encourage you to do it, especially if you're struggling with graphs. Look at it separately, right? Look at it just at the x-axis. Am I moving left or right? Look at it just am I moving up or down with your y-axis. All right. So what does this graph show us? So we have time, we have percent remaining, we have carbon-14. Right? We know nuclear decay is radioactive. It's shooting out these alpha, beta, gamma particles. And as it does that, it's decaying, right? Maybe carbon-14 is falling back down to carbon-12, or maybe it's transmuting to something different altogether. So first off, let's look at this half-life. What does this half-life mean? We're going to start up here at the top, right? At 100%. So now, as time progresses, 1 year, a year and days, right? We're going to slowly start to decrease. So it might be different rates, kind of fast, slow, whatever. Right? We're slowly decaying. We're slowly decaying. We're slowly decaying. Right? And then we get to this point here where we have half of it is decaying and there's half remaining. So once we get to half, right, we look at it just as up and down, right? Once we have gone down to half, right? I'm not worried about if I'm moving left or right at all. I know that I have gone down this line and I've gotten to the half point. All right. So we know down to half, right? That's it. That's all. That's all this tells us over here. But then we can look at our x down here, and we can say, okay, well, I moved that way. I moved to the right 5,700 years, right? So we know. Then we can put them together, right? I moved right 5,700 years. I moved down 50%. This is my half-life. It took 5,700 years for half of the carbon atoms, the carbon-14 atoms, to decay, to emit radiation, to change, to transmutate to whatever else they are now, right? There's still mass. We didn't destroy any mass, but it's just in a different form. It took 5,700 years, right? It's constantly decaying, right? Constantly. And, kind of best way to think about this is you're constantly getting older every single second of every single minute of every hour of every day. You're constantly getting older. You're changing in age. But we don't say, hey, today I'm 30 years and 180 days old. You say I'm 30 years old, and I will be 30 years old until the day that I turn 31. And that don't mean that I just stayed 30 until I became 31. It just means, hey, we don't really acknowledge that I'm getting older, right? We don't keep up with it every day, right? We're just gonna kind of keep track of it every year, right? So that's kind of the same thing with half-life. It's constantly decaying, every second of every minute of every hour of every day. But we're just going to kind of take note when it gets to half. We're going to track the half-lives, and then we can kind of work from there. So that's kind of our first thing. And then every 5,700 years, down to after two half-lives, half of 100 is 50. After another half of 50 would be 25. That took another 5,700 years. And then we can even go, half of 25 is 12.5, right? That's another 5,700 years. So, we're down to 12.5%. It took 17,100 years, according to this not drawn to scale graph that I made here. It took a long time to get there. You can go down to 6.25 and 3.125. You can keep going, but it will get to half of whatever it started with every half-life. So, we can say something. If there's only 12.5% left, we can say, how old is something that has decayed so much? There's only 12.5% of carbon left. We can go down here to 12.5%. Right? We can crawl over. We can find our age right there. It's not a problem. Okay? It's very simple. I don't know. I guess that's about it, really. It could be giving you, if you see a test question, it may not give you the half-life. Most of them are going to be like, the half-life of carbon is 5,700 years. How much remains after 11,400? And then you would solve it. But it might just say, how much of a 4,444 gram substance remains after 17,100 years. So it'll be expecting you to look at this graph and be able to be like, all right, well, I don't know. But I know that the half-life is 5,700 years by reading this graph. I know after 17,100 years, I've gone through 1, 2, 3 half-lives. Well, I just know my sample went through 3 half-lives. So after one half-life, we're down to 2,222. All right, that would be a total of 5,700 years. Then after another half-life, it would be 1,111. That'd be after 11,400 years. So it would keep going, and then you get down to 17,100 years, and that would be my answer. Sorry, I dropped the top, threw me off. This is the basis of half-life. You're just dealing with packets of time that represent half, right? We have a packet of time that represents our age, which is 1 year. We use this packet of times. How old are you? Well, I'm 30 years old. There's been 365-day packets passed since I've been alive, right? Half-life's the same thing. How old is it? Well, 3 half-lives, 3 packets of time have crossed. It tells how the age is. So, if you have any questions, let me know. Thank you for watching this video. Kind of rundown of using the graph to help us solve or identify half-life and what's going on and define it, be able to read it. I hope this was helpful. Stay posted for more videos.